So, if you aren't aware, there is a new chapter in the speculative decoding story. If you don't know what speculative decoding is, our most recent iteration before DSpark was MTP, multi-token prediction. And without getting too nerdy, all models work with a prefill and a decode. So the prefill is your input and the decode is guess what comes next. That's your, that's how LLMs work. They're just trying to predict the next thing. Speculative decoding was the first advance. I think it came with the Gemma model. And that was, let's use a draft model, like a little model, and have it do the decode. So you send your input to the draft model, and then it sends its guess to the target model, the model you're really trying to use, and then it validates that as a good or a bad guess. Then we get MTP, which is multi-token prediction, which is like, hey, instead of doing one at a time, let's do a bunch at a time. And it still does it in an auto-regressive manner, which means it just tries to guess the next one after the next one after the next one. And once you get to a bad one, that entire chain of tokens is bad. And then it does the same process, and the model, validates it in a block. And this leads to this thing called Suffix Decay. So Suffix Decay is in that chain of tokens. As soon as you get one that falls below a certain threshold, that's the suffix, that part of it. So like, the first one's like, I'm 98% confident on this one, and the third one's 30% confident. And if that's below the threshold, the rest of it is garbage. So there's some accuracy issues with MTP. It's fast, but accuracy can fall apart. So DSpark does more or less the same thing, but it does it in this semi-autoregressive generation. So it's not doing it completely sequentially. It's trying to do it in blocks. And then it does this, the second part of the framework is, I don't see it on this document, but it's sort of their hardware-aware confidence scheduler, which trims up the draft tokens based on available resources. So if you're under a heavy server load, it's going to throw away a lot more garbage a lot quicker. What I'm actually really excited about is this project called mlx-dspark, which brings both DSpark and DFlash to native MLX on, Apple Silicon. There's a bunch of stuff here. This is a really cool repository, a lot of good information and statistics. It's just Python, so pip install or pipx or UV or whatever you want to do. So I've got two terminals here. I've already installed mlx-dspark. I'm going to run one command up here and one command down here. Now they are identical. And what I'm running up here is generate this model, Qwen 3 4 billion 8-bit. This prompt, give me a writing prompt just because I use that often. It seems to generate a lot of thinking. I've got max new tokens set to 128,000 because for some reason the default is 220, and that's going to cut off a response way too early. And then the important difference between these two commands is here I have mode baseline, and down here I have mode dspark. So I'm going to run this guy up here. Now I've already downloaded this model. So it's skipping that part. But if this is your first time running that model, it is going to download the model. Now, an important thing about the models, this actually only works with a handful of models right now. I imagine tomorrow it'll probably run on more models. So keep an eye on that repository for updates. I think the thing I'm more excited about is I think this is going to come to mlx-LM. And for me personally, more importantly, I think it's going to come to oMLX in time. So this was 29.05 seconds, and we got 23.2 tokens per second. Now I'm going to run the DSpark version of it. So we can see it's doing a little bit more, and it is acknowledging that we are in the DSpark speculative mode. Visually, this seems to be running a bit faster. So, okay, so this took 18 seconds versus 29 seconds, and we got 37.4 tokens versus 23.2 tokens. That seems pretty significant. Now, what I'm going to do is I'm going to pause this recording and go find another way to measure this, because I'm not one to really just believe in a library's own benchmarks. So what we're going to do is we're going to run mlx-dspark as a server, which is an option here. Got the same model. I'm disabling the prefix cache. When you run this in the command line, for some reason, it's max draft instead of max new tokens. I think that's the same, but since I'm just going to run the same test twice in 2 different modes, I guess the result should be proper. I've got no thinking on, and I'll explain that in a second, and then mode of baseline. Now, I'm using this really cool library I found called OpenAI LLM Benchmark. I will leave a link to that in the description. But what this does, you can actually tell it to do a bunch of requests and all sorts of concurrency, but you just point it at an OpenAI URL or compatible API URL, put in the model name, the number of requests, and the concurrency, and it's going to spit out a number for you. The reason I disabled thinking is because when thinking is enabled and the API returns that, this acts as though that's the response and it messes everything else up. So we're going to run this on baseline. Whoops, I'm going to run the server first. And now we're going to run this against the baseline. And we get 21.27 tokens per second. All right, now we're going to clear this out. We're going to run this guy in dspark mode. Clear this up, and we'll run the exact same command, and we'll see what we get. Whoops, I didn't start the server again. All right, server's running. And we get 37.69 tokens per second versus 21.27. So I'll be the last one to pretend that that is a super scientific or well-coordinated set of tests. But it seems really legit. I've run it through a bunch of different tests. I've run it a whole bunch of times, and the results are pretty consistent. Now, this is with a bunch of smaller models, so keep that in mind. But the results we got with the CLI directly were 1.28 times faster. And the result we got with the OpenAI LLM benchmark tool that I was using was 1.77 times faster. And if you average those out, it's 1.5 times faster. And yeah, I'm really, really looking forward to using this with larger models. I'm Joe Metalone. I make short, practical videos that respect your intelligence and your time. If that's your style, you'll like this channel.